Alright, so problem number 2 on the review is looking at the distribution of television sets. And it says, hey, you have 0, 1, 2, or 3 television sets, and your probability distribution is 0.05, 0.19, 0.32, or 0.44. And so these are all the different probability distributions that you can have. And so the first question says, hey, find the probability of randomly selecting a household that has the probability of having 1 or 2. And ORs from probabilities add. So we want to take the probability of 1 or 2 and add them. And so the probability of 1 is 0.19 and the probability of 2 is 0.32. Combining those together, I get 0.51. So if I were randomly to select from this distribution, I would have the chance of getting a 1 or a 2 would be 0.51 or 51%. Now the probability, the second question asks the probability of selecting a household that has 2 or more, so that the probability is greater than or equal to 2. Well, if I look up here, the only probabilities I have that are greater than or equal to 2 are these two probabilities, 2 and 3. So for this, I want to add the probability of 2 and add the probability of 3. That will give me the chance of selecting either of these. And so the probability of 2 is 0.32, and the probability of 3 is 0.44. And I put them together, I get 0.76. For part C, it says find the probability of randomly selecting a household that is between 1 and 3. So, okay, between 1 and 3. And it's saying inclusively. So that's the probability of 1, the probability of 2, and the probability of 3. Well, there's an easier way of looking at this, which is, hey, you know what? 1, 2, and 3 is everything but 0. And so we could look at the probability of 1 of 3 as being the complement. Right? So the P of 1 minus 3 is equal to the complement of the probability of 0. And so we could say that the P of 1 minus 3 is equal to 1 minus the probability of 0, because that's what the complement says, or 1 minus 0.05, or 0.95. And then the last question in this section says, find the probability of randomly selecting a household that has at the most 2 televisions. And so at the most is 0, 1, or 2. It's everything but 3. And so we use the same idea here for at most 2. So probability of being less than or equal to 2, at the most 2, is going to be everything, because 1 is everything, minus the probability of 3, which is 1 minus, well, let's look at the probability of 3 here, 0.44, which is equal to 0.56. And so we've calculated the probability that it's asking in question number 2.